for today, we're going to go on to multiplying and dividing rational numbers. So we already established the rules when multiplying the integers. With rational numbers, it's still the same rules because the operation is still the same. So, the same processes and rules apply to multiplying and dividing rational numbers. So now we're talking about fractions and decimals. So really, this lesson is more about making sure we're reviewing those rules for those operations and reinforcing the integer rules. Okay? If the signs are the same, the answer is positive. That's our love situation. If they're the same, it's positive. They love them. The signs are different. The answer is negative. Okay? The process is going to still be the same. So we're going to go through that same process. Let's just review the rules really quickly. So in this case, 4 and 5100ths times 3. So I just write the number 4 and 5100ths times 3. Who remembers what my rule is for doing the multiply?
You count how many decimals there are to the right up on the thing circling it, and then you can just multiply normally and put the decimals.
Perfect. Count how many decimals I have total. Then I ignore the decimals. I'm just going to multiply 451 times 3. So that's going to give me 3, 15, 12, 13. Once I get to the answer, then I see my decimals and I put them back in. So this one is going to equal 13 and 5300ths. Once I've done the math, same as with the integers, now I compare my signs. In this case, they're both positive, so my answer will be positive. That's my answer. Make sense? Okay. So I've given you guys an example. You've got 5 more of these to do, 4 more of these to do. I'll give you guys about 4 minutes.
Thank you.
Okay, you guys should have had this one done by now. So again, when we're multiplying, I start with just doing the math. So 2.5 times 7, 1 decimal place, gives me 35. 17, 1 decimal place. Once I have my answer, then I compare. They're opposite signs, that means it's a negative. They hate each other. Okay? Next one. Again, we ignore the signs, we just do the math. It goes really fast. I have 1 decimal place, 12, 11, 3. Put my decimal back in. Compare my signs. This time they are both negative. That means they're the same, so we love each other. Positive. 32 divided by 5. Remember, the first guy, the top guy's the winner. He goes in the house. So that's going to go 6 times. Gives me a 2. I'm not at 0, so I need to bring in my decimal. That's going to be 20, so 6 4/10. So, 6 4/10. They're both negative. I compare my signs. That means my answer is positive. They love each other. Then, 20 divided by 3. 20 divided by 3, it won't go into 2, it goes into 26. 18, I'm still not at 0, so I add a decimal, but what do you notice? It's going to be repeating, right? So repeating means that's just going to go on forever. So my answer becomes 6 and 6/10 repeating. Compare my signs, negative and positive. They're different, so they hate each other. So negative. Quick sidebar, is that the only way I could have written that answer?
No. You
Oh,
write
good.
6.6 as a second and 6.7.
No.
That's what.
It didn't tell me I could round.
Oh wait, well you can write like 2.6 or 3.6. I remember 6.
What? No, correct. To do it correctly, seriously, guys, if it's this, I should not do that. The correct mathematical notation is the first time I see the repeating pattern, that's the only time I write it. So mathematically, although that technically would be correct, the way we write it mathematically has got to be like that. But you were saying I could write it that way.
You said 6.6667.
Well, there's another right way to write this. What's the other right way to write this?
2/3 fraction.
It was a mixed number. I could have written it as -6 2/3. That was what I was looking for. Good job, Danny. Okay? On this one, using the last 2 problems, how would you explain to a friend when to stop simplifying a rational value through long division? How do I know when to stop, Shane? 'Cause I know that's what you're talking to Ryan about.
I don't want to stop simplifying. So, what do you mean by that?
Carson?
We get to the third decimal place because money only goes up to 2 decimal places.
We're not talking
Were
about
those money
We're
problems?
talking about money.
Well,
we're not talking
It
about
doesn't matter about it.
well,
I like her. At least she's thinking about it and gave you an answer, Shane.
Well, I
And
would.
technically, she's correct. If I know I'm dealing with a money problem, I know I stop at the third decimal place because I'm going to add round. I know I need to go past that.
Yeah, but we're not
But
talking
it's specifically talking about the last two problems. Neither of those were money. So how do I know when to stop simplifying? Okay?
Go to the third number after the decimal because usually we're doing
How do you know when to switch?
No?
It's when
There you go.
you reach the
when you
last
see it repeat in a row,
Okay, that's one. What's the other way I know to stop? Mia? Good. So, when I get to a 0, or I see a repeating pattern. I know to stop. Although I did like Carson's thought of understanding it's a word problem and it's money, then I know I'm not going to go past the third decimal place. So using the problem in context will also give you an idea of when to stop. Sometimes your directions are actually going to specifically tell you where to stop. So technically there's two more, but because it was talking about the last problems, that was where we saw it come to a 0 and where we saw a repeating pattern. Those are the two where you always know, but do pay attention to your problem as well. Does that make sense for everybody? Questions on it? Okay. The next one. Cell phone company charges Michael a late fee of $3.80 per day until the balance is paid. If Michael is 8 days late, what is the change in Michael's bank account? How do I set this one up? Brandon? Oh, you were just itching your head, sorry. Nolan?
Like 3.84 times 8.
So 3.84 times 8, right? No, why not?
it's what I didn't set it up like that
Why not?
because you can't really move the decimal to like get your 2 decimal points to put in the equation after. It's just hard.
Okay, so you're saying I'm just saying how do you set it up, not for showing the work. I agree with you. Showing your work, you're gonna go like this, right? 3.84 times 8.
Yeah, so
But I'm just asking to set up the problem, to model what it says.
Can we still do the, like how he explained it? Can we still do it? Or do we have to still
I don't understand your question, Peyton. No, re-ask it. I want to make sure you're clear.
like how do you say it? Could we still do it for the same question, like just to write it out still, or?
Yeah, I mean this would be your expression, right? Is everybody good with that?
yeah.
Guys, why are we not paying attention?
What?
What is the 384?
The late fee per day.
It's a late fee. So it should be a negative, should it not?
It should.
Does that make a difference?
Yes.
Yes. I mean, mathematically it won't until I get to the solution. As far as the setup, technically I don't, because when I do this, I'm ignoring the signs. But we're, again, talking about how do I set my problem up correctly. That is what the problem tells me, yes?
Oh, yeah.
Okay, so now I just do the math. I've got 2 decimal places. Gives me 32, 64, carry the 6, 24, 30, put in my 2 decimal places. and compare my signs. Negative times a positive means it's a negative. Yes?
But the answer will be positive because it's asking for the change. So the change is not need to be the actual value of it, which will be positive.
Is it?
Huh?
I think so.
So you would say, for your answer, you would say the change is $30.72?
Yeah, because
Huh?
yeah.
So he's getting $30.
Actually, I'm glad we're having this discussion. I had this discussion earlier. So the way I would write the answer, the change in his account
Went down by 30.
is negative $30.72. This is how I would have written the answer. Why couldn't I put $30.72? Because that would indicate it went up.
Yeah, because then it's like a
Did his account go up?
No.
No. It went down. Now, Nolan, to your point, and what you were getting at is it went down $30.72. So if you had said it that way, technically it would be correct. But I've been trying to train you guys to do what? Mark your text, which includes boxing your question. What was my question?
What is the change?
What is the change? So if my answer was it went down $30.72, would that be correct?
No.
Technically it would be,
Because it
because
went
I
down.
did show it went down, but the way it was phrased is what is the change. So my answer should address what is the change, yes?
Yeah.
So do you understand why I wrote it the way I did?
Yes.
Okay? Would it have been okay to say his account went down $30.72? Is that
Yeah.
acceptable?
Yeah.
Technically it's acceptable, and I would accept that answer. But again, I try to model what I try to teach you guys, which is use the question they've given you to write my answer, to make sure I'm addressing the question. Does that make sense for everybody?
Yeah.
Do you understand the math behind it?
Yeah.
Do you understand why we set it up with that negative sign?
Yes,
Yes.
because it's going down. And he's getting
Anybody
charged.
confused on any of these steps? We're all doing good?
Yeah.
Good. Okay, now let's talk about multiplying fractions. If I am multiplying fractions versus decimals, we have to go back to our rules again. The first rule is we need to change our mixed numbers to an improper fraction. Actually, this class, oh, no, I have one here that wasn't here with me last year. So, when we talk about this, we use the basketball analogy, right?
What is it? LeBron James versus-
If I am going to change a mixed number into an improper fraction, you can think of it as basketball. In a basketball, if I'm going to do a slam dunk, it goes really fast, right? And this is, as the player's running towards the basket, he goes super fast, and he goes underneath really quick. He brings it up, and then he just kind of holds it there as he floats to the basket, and then he slams it in, right? So this is just like basketball. I go really fast. I'm going to multiply the bottom times the whole number, and then I'm going to slam it home by adding in my numerator. So when we talk about this, you're going to hear me use the term slam dunk. That's what we're talking about. So the first thing I'm going to do is rewrite my problem, 7/8. 2 times 1 is 2, plus 1 gives me a 3. And once I've done that, now I just multiply the numerators. 7 times 3 is 21. Multiply the denominators. 8 times 2 is 16. And my final step is I simplify. How many times will 16 go into 21? 1 whole time with 5 left over. Oops. 5 16ths, not 21st. Then I compare my signs. They're both positive, so my answer will be positive. They're happy. They love each other. Does that make sense for everybody?
Yeah.
Okay, so that's what we do with multiplying fractions. When we do dividing fractions, we have to add another. Shane, sorry, question?
If you have two negative numbers that can multiply in one volume, what would it be?
Positive.
So if you have two negatives times the positive.
2 negatives means it's positive, yes? And then positive times positive is still positive. They're still
But
the
what
same.
happens if we're positive times positive times negative?
That'd be negative.
So it doesn't change no matter what. It's just
Positive times positive is positive. They're the same. Then I have a positive times a negative, so they're different now. So now it's going to be negative. Quickly.
like if I have 100 positive, why negative? Would it still be negative?
Basically, when you get down to it, you're just going to do a comparison. If I have an odd number of negatives, it's negative. If I have an even number of negatives, it's positive. Okay? Okay, for dividing fractions, we have an extra step in here. Because I have a mixed number, the first thing I have to do is slam dunk. So I'm going to do the 4 times 2 and then add the 3. That gives me 11 fourths. I do highly recommend rewriting your division problems after the slam dunk, before you do the next step. Because we don't actually divide fractions, we multiply by the reciprocal. The way we do that is our key change flip. So I'm going to keep the first number like it is. I'm going to change it to multiplication. I'm going to flip my second number. Then I just do that math just like it's multiplying fractions. So 11 times 3 gives me 33. 4 times 2 gives me 8. For simplifying, 8 goes into 33 4 times with 1 left over. Compare my integers. They're both positive, so my answer is positive. They love each other. Get all this written down. Here. I put it up here for a reason. Any questions on these? Are you guys understanding the rules?
Yeah.
Okay, we're down to 10 minutes, so I'm going to run through these with you. Yes. Now, one step they didn't add in what they did, this is a Mr. Moore one that I love to do, is my reduction, right? If I have the same factor on top and bottom, I can get rid of them to make the math easier. In this case, I see a 3 on top and a 3 on bottom. So I can divide both those by 3 to make them 1s. So now I just have 1 times 2 is 2, 5 times 1 is 5. They're both positive. That means they love each other. It's a positive answer. If you do not like to do the reductions, that's okay. I do 2 times 3 is 6, 3 times 5 is 15. I know I can divide both of those by 3. Gives me 2/5. You should get to the same answer. The problem is you've added a couple steps and you've made the math harder. Because now you've given yourself 2 additional chances to make a math error. With smaller numbers, not such a big issue, but as the numbers get bigger, that becomes a problem. Right, Ryan?
What did Ryan do to that?
Ryan's just not paying attention again. Okay, again, we're multiplying.
Wait, can you make
I highly recommend look for your reductions. I have a power of 3 right here. I can do 2 times 3 and 1 times 3. That's the only one I have, so now I just multiply. 5 times 1 gives me 5. 2 times 4 gives me 8. Negative times a negative. That means they're the same. Same ones mean they love each other, so it's going to be a positive answer. Your next one. Uh-oh, now we're doing division. Before we can divide, we have an extra step. Big caution on your simplifying. You cannot simplify a division problem. You have to do the key change flip. It's got to be multiplying to simplify. So I'm going to keep the negative 3/10. I'm going to change the multiplication. I'm going to flip. I don't change the sign. I only flip the numbers. Okay? Once I'm in a multiplying, now I can look for reductions. So I've got a factor of 5 I can take out in both of those. Now I'm done. 3 times 1 is 3. 2 times 4 is 8. Negative times a negative. They're the same. That means they love each other. Positive answer. Another division. So I have to do my keep, change, flip. Keep the negative thirds. Change. Flip it. 2/1. Now's where I look for reductions. If you try to reduce here, you're going to mess it up, guys. You cannot do that. So now I do 2 times 2 is 4. 3 times 1 is 3. I can further simplify that to make it 1 1/3. Negative and a positive. They're different. That means they hate each other. My answer is negative. Okay, now we also have a mixed number. That means we need to slam dunk it first. So 2 times 2 is 4 plus 1 gives me 5 times a negative 3/4 Look for any reductions. I don't have any. So 5 times 3 gives me 15. 2 times 4 gives me 8. 8 goes into 15 once with 7 left over. We have a positive and a negative. That means they're different. They hate each other. It's a negative. Any questions so far on this? Okay, we've got about 6 minutes left. I'm going to give you guys time to see if you can figure out the bottom one
Wait, can you start handing out?
while I hand out your homework.
I'll just keep it to remind.
Do one. Forgot to do this one, so just really quickly. Negative 8 ninths. Change. Flip it. Negative 9 fourths. Again, your reductions make it super nice because those go away. Those go away. And I just have 2 over 1, which equals 2. They're both negative, so that means they love each other. It's a positive. Here's the one I thought we were at. The way I would do it, I would read the problem and model it first, because that's going to help you understand what it looks like. It dropped 6 inches over 2.5 days. By how much did it change each day? So when I'm looking at something like this and it's going down to each, that's telling me it's a division. So a negative 6 divided by the 2.5 days. So when I look at my problems, there's the one that is written that way. Doing the actual math, negative 6 over 1 divided by 5 halves, negative 5 halves, 5 halves, means I keep, change, flip. So that's going to become 12 fifths, which equals 2 and 2 fifths. A negative and positive, they hate each other, so it's going negative. So from there I would go to that answer. Deposits 250 each day for 6 days. So that's a positive times 6. Okay, you can watch the video if you need to. Good luck, guys. Have a great weekend. Enjoy your time off. Okay, the last problem over here. So 6 times 2 and 5 tenths. So if we just do that math, 2 and 5 tenths times 6, I've got 1 decimal. 30, 15, so that's going to equal 15. So from here, we're going to come down to this one. So for our last one, they invest in a stock that drops $250 each day for 6 days in a row. What is the change in AJ's investment? So the drop 250 is going to be a negative 250 for 6 days in a row. So it's going to be a 6 times a negative 250. So that looks like this one here. So the math is going to be the same as what we had just done. The only difference is it's going to be a negative, meaning that this one goes to there. Okay, good luck, guys. Don't forget to sign up for the seminar if you have any questions.